Strongquist is the CEO of Strongquist & Company, a master distributor of building automation and HVAC controls. He's also the founder of ControlTrends.com and the co-host of Control Talk Now, the Smart Buildings videocast and podcast. He can usually be found camera in hand tracking down smart building experts around the world, getting their thoughts on how to make buildings smarter and more energy efficient. Please welcome Eric Strongquist.
Everybody hear me okay?
All right, it's great to be here. So in a moment, I'm going to show you a proven strategy that you can reduce your energy spend on your heating and cooling by 25% or more, at the same time improving tenant comfort, and at a return on investment that would make Warren Buffett envious. It's going to work on about 95% of your applications with chilled water and hot water. So first, at Strongquist & Company, we help our customers save energy, improve building performance, and reduce operating expense through the proper use of building automation, control systems, and HVAC controls and data analytics. So at Strongquist & Company, we work with independent contractors, and we handle multiple product lines, everything from Honeywell to Johnson Controls to Siemens. And the reason we do that is primarily because we feel like that one size doesn't fit all. And by being able to handle multiple product lines and working with multiple contractors, we're able to help you make the best possible choice for your HVAC and building automation control systems. So about 6 years ago, the technology has been changing so rapidly, I started a website called ControlTrends.org. It's a way to keep myself educated as well as to educate our clients. So I get to interview people like Daryl Smith from Microsoft, who only has 15 million square feet underneath his purview, and guys like Jim Young from Realcomm Ibicon. It's kind of become a worldwide phenomenon. So I got some good news and some bad news for you. Bad news is, if you're going to try to reduce your energy spend by 20% by upgrading an existing energy management system, is probably not going to happen. The good news is, by upgrading your system and using proper data analytics, you can realize huge operational savings. Okay, so to understand our solution, you first have to understand how your building, a couple of things about how your building was designed. First of all, I can pretty much assure you the equipment in virtually everybody's building here is oversized. And there's a simple reason for that. When the engineer designed your building, they knew that if they undersized the building, it was a possible lawsuit and a career-ending mistake. If you oversize it, you just have some existing capacity. So that's the first thing. So all your pumps, your piping, and your air handling units are probably a bit oversized, and that gives us the ability to really implement a cool strategy that I'm going to tell you about in a second. The other thing you have to understand about your building is the way it was designed under worst case scenario. So for your chill water system, it basically meant it was designed on the hottest day of the year, around the hottest day of the year. So it works really, really well as long as it's the hottest day of the year, but on other days, it's not quite as efficient. That's primarily because the system is based also off of pressure drops. So everything is dependent upon pressure. So most of you are going to have air handling units that are going to have chill water coils, and those coils are going to have valves that open and close to give you more or less cooling. Those valves are what we call pressure dependent valves. So that basically means that it's very difficult to get them balanced. And the nature of your coils are, they can flow or overflow. They can take more capacity in than they can actually use. So how do we balance our coils in such a way that we get 100% efficiency? So instead of controlling off of pressure, what if we controlled off of delta T instead? And quite simply, delta T is the difference between two temperatures. In the case of your coil, it's the difference between your supply temperature and your return water temperature, which interestingly enough is how your coils were sized to begin with. So you take the difference between the supply temperature and the return temperature, and you get a maximum amount of cooling, or BTUs. The coils can have more water or be flooded or overflowed, in which case you have waste there, and they can be underflowed, in which case you're not getting enough cooling. That's where your nuisance calls come in. So with our solution, we're going to save money by reducing the waste at the coil level. Also, we're going to save a lot of money with the pumps. So keep in mind that the water's got to come from the chiller. It's got to be pumped up to your units. So pumps are kind of interesting. So if you reduce the speed of the pump a little bit, you save a lot of energy. And consequently, if you're overspinning your pump or overusing your pump, you're spending a lot more energy than you need. in that if you reduce the pump speed by 20%, you're going to get a 50% energy reduction. So that is called the pump affinity law. We're going to control our coils very, very efficiently. We're going to reduce our pump speed needed, and we're going to reduce the amount that the chiller has to operate. So without further ado, I'd like to introduce you to our solution. Ladies and gentlemen, meet the Belimo energy valve. So the energy valve is a specialized control valve. In front of that, we put a flow meter, and we have two sensors, one for the supply and one for the return temperature. Again, this allows us to dial right in to controlling the coil at the maximum coil efficiency. Now, the other really cool thing about our solution is that you can take that data and you can run that back to your analytics package or to your energy metering package for your leads point. But again, we're going to control off of delta T, reducing the amount of energy the chiller needs, the amount of pump energy we need, and also making the coils more efficient. Okay, so does this work? Well, let's take a look at a couple of case studies. Let's start with MIT. They take their engineering very, very seriously. Keep in mind at MIT, they had energy management systems already in place. They looked at the Hayden Library as a test site. They put in 6 energy valves. The average return delta T off of the coil was 6.5 degrees. After the same period of time, the results were pretty astounding. They were able to raise their delta T by about 6 degrees. This resulted in using 49% less energy to pump the same amount of chilled water they needed, while at the same time reducing the pump speed by 25%. They estimated they took this across campus, they would save $1.6 million. Okay, the next one I want to talk about is the Rosenthal building at the University of Miami Hospital. This is very critical here in terms of making sure that we got precise temperature control. Had 11 air handling units, roughly 2,600 tons of cooling. Able to raise the delta T, reduce the pump speed by reduce the pump energy used by 5,600 GPM, roughly $66,000 a year in payback. Okay, and finally, a little bit closer to home, we have the Sam Nunn building. GSA reached out to us about a year or so ago. They'd done everything they knew how to do in terms of energy management and lighting control to reduce their energy spend by the government mandated 20%. They came to us, we put some energy valves in at GSA. We just got back last week. Essentially, they were able to take the same unit, same degree days. Instead of taking 100 GPM, they were able to run it through at about 30. So they're getting ready to do 5 more energy valves. So you guys all look like very reasonable people. So as this gentleman said, we want to make you an offer you can't refuse. If you look over there, that's Tim Chambly in the red shirt. Reach out to Tim. We've set aside 7 energy valves for the Better Business Challenge. And the way this would work is you guys come to us, we'll come out, we'll survey your building, we'll get you an energy valve, we'll make sure you get it installed properly, we'll help set it up properly. At the end of 6 months, if you like the energy valve, hey, give us a purchase order for it. If you don't, take it out. We'll give you $250 for your trouble. Thank you very much. See you at the booth.